today's goal of this lecture till long day after. Today I will discuss some question on linear algebra which had come CSIR NET 2024 June exam. The question is VBA, first question, VBA finite dimensional vector space over R, and T be a mapping from V to V, be a linear operator. Suppose that kernel T equal to image T. This is very useful portion. Kernel T equal to here image T. Then which of the following statements are necessarily true? Option 1, dimension of V is even. Option 2, trace of T is 0. Option 3, the minimal polynomial of T cannot have two distinct roots. Option 4, the minimal polynomial of T equal to the characteristic polynomial of T. Here given car T equal to image T. And we all of us know dimension of V equal to dimension of car T plus dimension of image T. Since given car T equal to image T, so 2 car T equal to dimension of V. So from this it implies dimension of V always even number. Next, the question about trace, minimal polynomial, characteristic polynomial. Since car T equal to image T, if Tx belongs to image T, same Tx also belongs to car T. Apply T again, then Tx, since Tx belongs to car T, that means this value is equal to 0. That means that imply T square equal to 0 operator. And this is means this is the nilpotent operator. And we all of us know the nilpotent operator, in nilpotent operator trace always 0 because eigenvalue is in nilpotent operator all eigenvalue are 0. So trace T is 0. This will be the right option. The minimal polynomial of T cannot have two distinct roots. This is also right option. And the minimal polynomial of T equal to characteristic polynomial. This is also wrong option. And this is true because we all of us know the root of the minimal polynomial is the root of the operator. And for nilpotent operator, always eigenvalue is 0. So minimal polynomial cannot have distinct root. And option 4 is not true because minimal polynomial for nilpotent operator, it is equal to characteristic polynomial. This may or may not be true. And it is depends on the operator T. So this is always not true. That means option 1, option 2 and option 3 are being similar type proof. Let V be a finite dimensional vector space and T be an operator from vector space to vector space which is linear. If given rank T equal to rank T square, then prove that range T intersection nullity T equal to singleton set 0 and V equal to range T direct sum null space of T. For this, let Y belongs to range T intersection nullity of T. Since Y belongs to range T, that means there exists a vector x belongs to V such that t of x equal to y, and since y also belongs to null space of T, therefore T of y equal to 0. Now apply T here both side also again, then T of x equal to T of y, that imply T square x equal to 0, that imply x belongs to null space of T square. And by rank nullity theorem, dimension of V equal to rank T plus nullity T, which is equal to rank T square plus nullity T square, and given that rank T and rank T square are same, since nullity T contain nullity T square and dimension of nullity equal to dimension of nullity square, therefore nullity T equal to nullity T square. Therefore, x belongs to null space of T square imply x belongs to null space of T, because nullity T equal to nullity T square. Therefore, y equal to Tx, y equal to Tx, since x belongs to nullity T, this value is equal to 0, and y belongs to range T intersection nullity T. Therefore, since I have got y equal to Tx equal to 0, therefore range T intersection nullity T contain only singleton set vector. Since range T intersection nullity T contains 0 vector, therefore x belongs to null space, therefore x belongs to null space of T square imply x belongs to null space of T, because nullity T equal to nullity T square. Therefore, y equal to Tx, y equal to Tx, since x belongs to nullity T, this value is equal to 0, and y belongs to range T intersection nullity T. Therefore, since I have got y equal to Tx equal to 0, therefore range T intersection nullity T contain only singleton set vector. Since range T intersection nullity T contains 0 vector, since rank T means dimension of range space of T and nullity T means dimension of null space of T. Since dimension of range T plus dimension of null space of T equal to dimension of V, and I have got 0 vector only contain range T intersection null space of T, therefore V equal to range T direct sum null space of T. I hope my all viewers have understood. Okay? Oh. Next question, which had come CSIR net June 2024 part B question. The question is V be a real vector space of 2 cross 2 matrix with entries in R, and T be a operator from vector space to vector space defined be a linear transformation defined as T of B equal to AB for all B belongs to V, B any arbitrary matrix, where A is the fixed matrix, A equal to 2 0 0 1. What is the characteristic polynomial of T? Here there exists one rules such type of matrix T of B equal to AB when B is any arbitrary matrix and A is fixed matrix. Similar type of question had come in CSIR net December 2014 exam. The question is MNK denote the space of all n cross n matrices with entries in a field K, and fix non-singular matrix A which belongs to MNK, then consider a linear map T from MNK to MNK given by T of x equal to Ax. Then question about trace, rank, and is T is non-singular? For this type of question there exists a rules. If TA be the mapping from n cross m to n cross m for general case by T of Ax equal to x, where for all x belongs to m n cross m, then if A has eigenvalue lambda, then arithmetic multiplicity of lambda in TA for TA, where x be arbitrary matrix, TA be the matrix from n cross m to n cross m, m times this m times arithmetic multiplicity of lambda in A. Similarly, null space would be m times null space of A, rank T would be m times rank of A, trace T would be m times trace of A. If you know this formula, then you can easily solve this question own self. Here, since n cross n matrix, that means trace would be n times trace of A. So option 1 is the right option. Since T is non-singular, here MNK denotes space of all n cross n matrix in a field K, fix non-singular matrix A. Here A is non-singular matrix. Since A is non-singular matrix, therefore the operator T would be also non-singular. Since A is non-singular, therefore rank T would be n times rank of A, and rank of A, since A is non-singular, rank of A is n. So this value would be n times rank of A. This is equal to n times n, which is n square. That means option 3 also right option. Similar type of question which had come CSIR NET 2024 June exam. Here the question about characteristic polynomial. Since here this is the diagonal matrix given, so eigenvalue of A equal to 2 and 1, and arithmetic multiplicity of lambda means here A, lambda of A is n times arithmetic multiplicity lambda in A. Here n means 2 cross 2 matrix, therefore 2 times 2 and 2 times 1. Therefore, from this we can tell the characteristic polynomial is x minus 2 whole square and x minus 1 whole square. So option 3 is a right option. I hope my all viewers have understood this type of question. This type of question actually very important for any competitive exam. Okay. See you soon. Stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.